Ever looked up at the night sky and wondered what's really out there? We see planets as serene, beautiful dots of light, but some of them are hiding violent, chaotic secrets. Today, we're journeying to the king of planets, Jupiter, to uncover a celestial feature so dangerous, so utterly extreme, it's been nicknamed the radiation belts of doom. Jupiter is a giant, more than twice as massive as all the other planets in our solar system combined. And with great size comes great power. Jupiter's rapid rotation a day, there is less than 10 hours long, spins its metallic hydrogen core into a frenzy, generating the most powerful magnetic field of any planet in our solar system. This magnetic field is a monster, nearly 20,000 times stronger than Earth's. While our magnetic field protects us, creating the beautiful auroras, Jupiter's does something far more terrifying. It creates a radiation environment unlike anything we've ever seen. Jupiter's magnetic field acts like a colossal cosmic net, trapping charged particles from the solar wind and, even more potently, from its own volcanic moon, Io. These particles are accelerated to near the speed of light, creating an invisible donut of deathly radiation surrounding the planet. These are Jupiter's radiation belts. To put this into perspective, you might have heard of Earth's Van Allen belts, a zone of trapped radiation that we have to carefully navigate with our satellites and astronauts. Jupiter's radiation belts are 1,000 times stronger than ours. 1,000 times, let that sink in. An unprotected human astronaut venturing into this region would receive a lethal dose of radiation in mere seconds. It's not just a hazard, it's a death sentence. The energy packed into these belts is immense. The total power is comparable to 10,000 nuclear power plants running at full capacity. The electrons zipping around have so much energy that they emit a constant stream of radio waves, making Jupiter the loudest radio source in the sky, second only to the Sun. Early radio astronomers were baffled by this Jovian radio noise until they realized they were listening to the symphony of its deadly radiation. So, how do we even explore such a place? For spacecraft, it's like flying through a firing squad. High-energy particles slam into sensitive electronics, corrupting data, short-circuiting systems, and degrading solar panels. It's a process engineers call radiation-induced degradation. Essentially, the spacecraft is being fried, bit by bit. When NASA sent the Juno spacecraft to Jupiter, they couldn't just fly straight in. It was an engineering challenge of epic proportions. Juno was designed like an armored tank. Its most critical electronics, its brain, are housed inside a titanium vault with walls half an inch thick. This vault, weighing about 400 pounds, reduces the radiation exposure by a factor of 800. Even with this shielding, Juno has to execute its mission with extreme care. Instead of staying in a stable orbit deep within the radiation zones, Juno performs a series of daring high-speed dives. It flies in a long elliptical orbit that swings it far out into safer space, and then for just a few hours it plunges between the planet and the inner edge of the belts, gathering data at breakneck speed before escaping back out. It's a cosmic game of chicken, repeated every 53 days. Despite these precautions, Juno's instruments have still suffered damage, a testament to the sheer ferocity of Jupiter's environment. This raises a fascinating question. If this region is so hostile, how do Jupiter's own moons survive? The planet has over 90 known moons, and several of its largest, the Galilean moons, orbit right in the thick of it. Europa, in particular, is a prime candidate in our search for extraterrestrial life, believed to have a vast saltwater ocean beneath its icy shell. But it orbits deep within the most intense part of the radiation belts. The surface of Europa is constantly being bombarded. The radiation is so intense it could sterilize any life on the surface and would break down organic molecules. So, how could life possibly exist in its ocean? The answer is its shield, a thick crust of ice. Scientists estimate that Europa's ice shell is anywhere from 10 to 30 kilometers thick. This massive layer of frozen water acts as a natural radiation shield, protecting the ocean below. The radiation that bombards the surface can't penetrate deep enough to reach the hidden sea, leaving the potential ecosystem within it safe and sound. The very thing that makes Europa's surface a wasteland is what allows its depths to remain a tantalizing prospect for life. But what about the other moons? Io, the innermost Galilean moon, is the source of many of these deadly particles. Its constant volcanic eruptions spew sulfur and oxygen into space, which are then grabbed by Jupiter's magnetic field and accelerated. Io is both the cause and a victim of this radiation hell. Ganymede, the largest moon in our solar system, has a trick up its sleeve. Incredibly, it generates its own magnetic field. This personal magnetic bubble deflects and carves out a small, protected cavity within Jupiter's larger magnetosphere, giving it a degree of protection. Callisto, the outermost of the four, orbits much farther away, outside the main radiation belt, and experiences a radiation environment hundreds of times weaker than Europa's. Its distance is its salvation. So each moon has its own survival strategy. Europa has its ice armor, Ganymede has its personal force field, and Callisto keeps a safe distance. Studying Jupiter's radiation belts isn't just about understanding a distant planet. It helps us understand the physics of extreme environments across the universe. Many exoplanets or planets around other stars are likely gas giants like Jupiter. Understanding how their radiation belts form and how they might affect their own moons is crucial in our search for habitable worlds elsewhere. Could a super-Jupiter in another star system have radiation belts that sterilize its entire system? Or could it have moons with even thicker ice shells, harboring oceans of life? Jupiter's radiation belts are a stark reminder that the universe is not always gentle. It's a place of extremes, of both breathtaking beauty and unimaginable violence. They are a no-go zone for humans, a barrier of deadly energy. Yet, they also hold the keys to understanding planetary formation, the potential for life in extreme places, and the fundamental forces that shape our cosmos. It's a radiation belt of doom, but for science, it's a treasure trove of discovery. Thanks so much for joining me on this journey to the king of the planets. If you found this as fascinating as I do, please hit that like button and subscribe for more deep dives into the cosmos. Let me know in the comments what cosmic mystery you want to explore next. Until then, keep looking up.